It was described as one of the most complicated missions ever attempted by NASA, landing a 1-ton rover inside a crater on a planet after a 500 million kilometer journey, and it went off apparently without a hitch.
Touchdown confirmed. We're safe on Mars.
Curiosity landed at 10:32 p.m. Pacific time on Sunday, 5:32 GMT Monday, and it wasn't long before the first pictures arrived. The Martian surface, in one picture framed by Curiosity's wheel. At a post-landing news conference, the scientists in charge of the program were welcomed like rock stars and could barely contain their excitement.
So that rocked. Seriously, was that not cool or what?
The jubilation at landing capped a tense evening as the craft, as big as a car, hurtled towards Mars at almost 6,000 meters per second. A parachute slowed it down about 11 kilometers above the surface, and then at 20 meters above the ground, a brand new landing procedure. A rocket-propelled crane lowered Curiosity onto the surface. None of this was controlled in real time. A 14-minute communications delay meant that it all had to be pre-programmed in advance. No room for error. Had anything gone even slightly wrong, Curiosity would have smashed into the planet and the $2.5 billion mission been a complete failure.
Nothing in robotic planetary exploration is harder, more technically challenging, or as risky as landing on the surface of Mars. And I know most of you are saying, how can he be saying that? It just looks so easy. Trust me. Historically, counting all the missions by all countries, the odds of success are about 40%. The recent U.S. record is better, with now 6 successful missions, including now 4 landings.
Now begins a projected 2-year mission. Chris McKay at NASA Ames in Northern California will use Curiosity to look for organic compounds in the Martian dirt.
Well, there's 2 important advances that I think Curiosity will bring to scientists like me. One is the ability to go up to different outcrops and different soil types and sample them, dig in and pick something up and analyze it. And the other is the instruments themselves are much more sophisticated than the previous examples. In the case of the instrument I'm involved in, the organic analyzer, this instrument has modes that the previous organic instruments, for example on Viking, did not have. And I think these modes will allow us to detect definitively on Mars the presence of organics. So I'm hoping that in a couple months I can stand before you again and say, yes, we know that there's organics on Mars, here's their concentration, here's the type of organics that are there. That's very exciting. It's the first step toward advancing our knowledge of whether there was life on Mars and could we find evidence of it.
With a team of 300 scientists working on the program, NASA hopes that's just one of many findings to come. Martin Williams, IDG News Service.